So I want to take a moment to discuss where we got all of these different steps in telling the story of how this rock layer came to be. This is important because this is what you're going to be doing on your first homework worksheet that's going to be due to me. So being able to understand this is definitely going to help you. So when we look at this section of rock, what we're going to do is we're going to use what we call relative age dating. So what we really want to do is we're going to tell the story of where these rocks came from and how they got there. So obviously when we tell a story, we want to start with our oldest. Obviously most stories don't start backwards and work their way right back in time. We're going to start with the oldest thing and go forwards. So from the different principles that you learned, the one that's going to tell us where the oldest is by using superposition. So superposition tells us that our oldest is going to be on the bottom. So we're always going to start these sections by looking at the bottom. Alright, so let's see what that means. So let's take our first step here. So we're going to start and we're going to look at the bottom. And when we look at the bottom, we can see there's a couple of things there, right? We have A, which is an igneous intrusion. We have E, we have H. Those three things are down there at the bottom. But if you look at this and we're trying to figure out which thing got there first, right, we can use that really important principle called cross-cutting relationships. Cross-cutting relationship tells us that if we have one object and another object cuts across it, that first object had to be there long before the one cutting across it, because it had to be there to let it cut across. And that's the case with A. So if we look at A, we see A is cutting across E and G and L and C and M and D and J. So that tells us A happened after all of those rocks were there. Alright, that those rocks had to be present in order for A to go through. So now let's go back here. We can look between H and E. Well, H is doing the same thing, right? It's cutting across G, L, and C. So that's telling us that H had to have happened after that. So that leaves us E. So our first step is going to be the deposition of E. All right, we've got to get that rock there. Now, if we look on top of E, well, first of all, there's a couple of things going on. If you remember, by using original horizontality, our rocks are originally deposited flat lying. This rock is not flat lying, so we're going to have to deal with that at some point. But if we look on top of E, right here, you see that there's a squiggly line, right? It's not nice and flat. That's our unconformity. So we have an unconformity sitting on top. We're going to learn in a couple of chapters, I believe it's either chapter 5 or 6, we're going to learn about the different types of different unconformities. Okay? So, let's keep moving on. After our unconformity, okay, the next thing that we're going to do is we're going to start moving up. So after that, we notice we have G, L, and C. There's no unconformities between them. They're kind of deposited in order, so that's going to be our next step. The deposition of G, L, and C. Now, if we take a look, we've got a couple of things to figure out. If you were wondering when we were going to deal with that tilting, well, we see that C, L, G, and E are all kind of tilted in the same way. So that tells us that the tilting happened after those rocks were deposited. However, we have another feature to deal with. We have our fault. Our fault is cutting across rocks that are already tilted. So that tells us, right, that we've got our fault and then our tilting. So our next is we've got our fault, and then they're all going to tilt afterwards. So you can say tilting or folding, whichever you prefer. Now, if we're going to keep, remember, we're just working our way up here, right? So now we've dealt with E, we've dealt with H, we've dealt with G, L, and C. Let's keep going up here. All right, if we keep moving up, since we've dealt with all of this, we can see before we get to our next layer of M, we have another unconformity there, right? So remember, an unconformity is a time where we don't have any deposition. Okay, so our next step is an unconformity. So unconformities are really important to recognize in the rock record because they tell us there's a period of non-deposition and erosion. Now we have to recognize that because we don't know how much time we're missing. We could be missing 10 years, 20 years, or a million years. So it's really important that we put that unconformity in there. Otherwise it would be like trying to read a book with 20 pages missing. All right, after our unconformity, we're just going to keep working our way up. So we see that M and D and J are all deposited in succession with no unconformities in between. So we can say we have the deposition of M, D, and L. Now, again, you notice that these layers are not flat. They originally started that way, but they're not. However, if we look further up, we see that N, K, and B are all kind of tilted in the same way. So we're going to wait to talk about that tilting until we get to after the deposition of B. However, we have something else to deal with. We need to take a look at A. A intrudes into all of these rock layers through J, but it doesn't move into N. It's truncated, you see here, by the unconformity. So this tells us that our igneous intrusion is older than the unconformity. So our next step is going to be the intrusion of A. Now we're going to keep moving up, just like we did before. And as we keep moving up, after A, we see we have that unconformity. So that's going to be our step 9. And after the unconformity, we can keep working our way up. We see that we have N, K, and B. So we have to deposit those. So we have the deposition of N, K, and B. Now again, we need to deal with that tilting. Because remember, all these rocks are originally deposited flatline. But we see that M, D, J, N, K, and B are all tilted in the same way. So that tells us that the tilting happened after B was deposited. So number 11 is going to be the tilting of M, D, J, N, K, and B. Now we're almost done. We've got to keep working up. So after B and after the tilting, we see our next thing that we have here is an unconformity. So our step number 12 is going to be an unconformity. After that, right, we have our next layer, layer F. So we have the deposition of F. Now if we look on top, and this is a step that a lot of people miss, we have an active unconformity going on up here. So our last step is an active unconformity. So I hope that helped you in seeing how I got all these 14 different steps. I'm going to do another, let's take a moment here after the next slide to kind of go through the ones that you're going to be seeing in your worksheet.